red, red, orange, 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 or yellow, orange, because you're supposed to do the primary, all right, and then yellow, okay? And then if you go to the next one, it'd be like red, red, orange, all right? And then you'd have the orange, red, or, yeah, and then orange or something like that. It would expand. The thing would go more because the yellow would have an extra. Each one around would get more, right? And so then to align certain things to keep a mathematical certain it would actually spiral. Hence the Kenny color spiral. And you'd be like, what? And you're like, look at an oscillator. You're looking at it like this from a side angle. But if you looked at it from here, what if that was a spiral that was spiraling in and out? Alright? And it's showing you like this, its wavelength on a 2D dimensional pad, or your screen, your pad, whatever you want to call it, your display. So, that right there can hold a color in the Kenny color spiral depending on a mathematical XY or XYZ, because you're just shifting so many, alright? And you're not going out. You could just like boom, 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 or boom, 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 which would be like boom, 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 boom. It's the same circle each time. It's the same color pattern, this one. So if you're using like a 36, and this one could be 12, or if you're going off the 360 one, because that's what would be the norm. That would be the balance. And the Kenny color spiral, the balance right there would hold when you go advance into the Kenny color spiral, you have both of them going like this. So, alright, and that's kind of what it would look like right there. And so, yeah, because you have the negative, the balance, and the positive. And the positive is the positive refractory, which we can see, alright? But I'm trying to like, the balance the Kenny color spiral, alright? So you got your color, and each little like, what would you even call that? Your little woo, your little blah, 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 blah. Your setting, whatever, your mathematical formula for saying, hey, 3, then double this, then double that, then double blah, 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 blah. Yeah, 3, alright? Yeah, okay? So, because you're expanding your spiral, alright? Even if you hold your red here, these other ones will offset because you're putting one again, and then putting one again, and then putting one again, alright? And putting one again. So you're holding red in this line, alright? And so if I'm going to go red, then yellow, alright? So yellow's right here, okay? Technically, if I'm lined up, alright? Yellow's right here. Then I'm going to say, oh, I'm going to put orange, alright? So I'm going to go red, orange, yellow, alright? So then it would go red, orange, and then yellow, right? So yellow is actually 2, or has, at the very least, has a separation of 1, alright? We're going to go say a separation of 1 from red, alright? This is the separation of 1, red, yellow, alright? So now, we're going to add another one in here, alright? Bam! That is red, red, orange, okay? And then you have like this yellow. It doesn't really matter after that what that other color is that you're trying to say yellow or in between. Notice how that rotation is happening. Notice how what we've been calling yellow keeps going in this circle. All right, it's just going to go like keep going like that. Each time you add something in, the yellow is going further around in the spiral. All right, so eventually it's going to hit back up here. So then, bam, you're going to go onto a larger spiral. Okay, you're going to hit the next one. All right. Do you understand that? Okay. I'm trying to make sure I'm explaining it correctly so it's easily understood. So, bam, the spiral goes this way, right? So if you were to say, hey, this is the mathematical, this is the mathematical spiral, all right? And I'm going to keep going like that. And then eventually, I'm honestly going to hit an end, okay, of, what would you call that? Repetition. Let's say that 33 1/3, you know, when you divide something or whatever, and it has that infinite blah, 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 blah. And it can always be the same number of blah, 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 over and over and over, all right? So, that right there would be like your end. That's when you know, okay, here, cha from... cha 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 red from yellow hitting all the way up here, saying that's basically a completion of that specific spot in the color spiral of going up in this mathematical, for lack of a better term, balance. That's saying, okay, this yellow has taken this spot of every little one here, okay? So you start off with red, yellow, blue. You put an orange here, okay? Now yellow's right here, all right? That's like your next one, bam. So, let's say you put like another orange in there, right here, okay? That means yellow would be right here, bam. That right there is like a complete, okay? Right on that. So as you go up the Kenny color spiral, as your colors expand from like a 3 to a 6 to a 12 to a 36 to 360 degree Kenny color spiral that has 360 colors all in it, you know, an entire color wheel of 360 little slots of color. When you go up like that, you see how the prior color wheel rotation of the three whatever, because here's the thing, with each one, after you go after that, the 6 has 1, alright? And you might say, well, this is a spiral. Alright, so I'm about to try to, I actually have two different things going on in mind. Okay, so anyways, you have your red, your yellow, and your blue, your primaries, okay? And that's when each one, because as you do your red, you may say, hey, my red's right here, so I always know blue's right here. But that's going to change as you go up, alright, in the Kenny color spiral, and you have to understand that. Because that's when you'll have more than one Kenny color spiral, okay? You'll double it, you'll multiply it, and you'll have this, and you'll just take like this color, and you'll match this mathematical color right here, and this mathematical formula over here, and line it up with this other Kenny color spiral that has this same color, but a different mathematical formula lined up upon it, alright? Because you can do that when you go further up the Kenny color spiral, alright? Because you go the 3, the 6, the 12, the 36, 360, alright? And so, look right there where it's red, yellow, orange, red. 6 is the red, or red, yellow, blue. Red, orange, yellow, right? Because the cha-cha, alright? So, even if it was like this, you're in like that, this is the easiest way to start out understanding the initial lowest common denominator of balance. Your yellow's right here now, all right? And now that's 3, 6, right? So then you go to the 12, okay? So now you have that, all right? So look at that. Now that's if you're looking at it in that way, okay? Now look at it, if this is the yellow, blue's here, red's here, right? Because we were going red, yellow, and then we put an orange in there that switched it over here, the ka-cha, alright? So, our red would be right here, right? And we started out with red, yellow, blue, 3. 6 was yellow here, 12, we're up here completing a cycle. That is right there. Our red we want in our line of red, right? So our next one, red, will be up there, right? Red will hold this spot, okay? So notice how there's 2 separate completions right there, all right? So that's when you're having 2 separate Kenny color spirals. Okay, and that's the easiest way to describe how this can occur in the balance. And if you're also using like negative refractory or positive refractory already has that like built in, all right? So, so your yellow is up there on your 12. Your 36 is your red, all right? So, on a line of red, you know right there from the start that you can actually whiteboard that mathematically of x and y, even x, y, z, because remember, we're going to do a x, y, z. You know, x, y, z. Yeah, you guys got the picture. Anyway, x, y, z. Alright? So, that right there, you can have that 1, 2, 3 jump in color when you actually see the color spiral in its form. Alright? And it's not the separation. Remember we were calling the separation. Remember the orange was this excuse me. Orange was that first separation, first degree of separation, whatever you wanted to call that, right? Because remember we had our red and our yellow, and then we had our separation that we called orange, right? Because it went red, orange, yellow. So, and then we put another separation in it, no matter what we called it, all right? So that's how we can call this X, Y, Z, whatever, right there. So many degrees of separation right here aligned up this color and the Kenny color spiral right here, and this was 3, 6, 12, 36, 360 degrees, right? 3, 6, 12, 36, 360 degrees, however you want to call it. And you can see how, like, if your red stays here in this straight line, your yellow is going to start spiraling out, you know, depending on how big your Kenny color spiral is. So, yeah, so depending on how big your Kenny color spiral is, your 3, your 6, your 12, whatever, ta-da-da-da-da-da-da-da, your thing will hit, all right? And you'll be like, that's a yellow hit, all right? But I'm waiting for a a red hit in the red line, even though I'm using red as the balance. Okay, got to remember that. Whatever you apply as the balance. So, if you have something that is not red, alright? Let's say you have something that's green, purple, or orange, right? Something like that. Even something that can sparkle. And we'll get to that on a different aspect of the Kenny color spiral, such as fractalized illumination or balanced illumination, which is on the positive side of the Kenny color spiral, not the negative, because the negative you do not see. That's the negative refractory that you would cloak or whatever shimmer, whatever that word is, go invisible, stuff like that. Stuff that would be ethereal. Stuff that's like we don't see in the wavelength of our eyes, because the spot that we're using. So if we go ultraviolet, which we're calling purple, okay, so violet is purple, all right? Ultraviolet has to have at least the 6, right? Because it's not on the 3 of red, yellow, blue. All right, so think of that. Say red, yellow, blue. Okay, if it's right there, it's not. You require the first degree of separation, right? So it doesn't matter what the fuck you're calling it. Red, orange, yellow. Okay. This blue, because we're going ultraviolet, right? Ultraviolet we know we have a degree of separation. And earlier we were calling it orange. I was calling it orange, right? But this we're calling violet, right? So we're on this, doesn't matter which side you're calling it, it would be over here. Ultraviolet, we don't see that, right? We don't see ultraviolet light. So ultraviolet's on the negative side of the refractory, all right? So we would start off on the, at the very least, the second one, the 6, because we need the violet, the purple, the in between the blue and the red. That's one's separation, all right? So the thing is, right there, we should be able to make a standard that says, hey, I easily can figure out, or at least associate, that whatever I'm looking for will also have a dividend of 6, okay? And you're like, well, that is obviously, look at what you're doing. You're going 3, 6, 12, 36, 360. And I'm saying, yes, that is correct. But with that said, further as I go into each one and develop these little patterns of figuring out how to place color in its mathematical frequency that I've already placed with like an oscillator or something else, a wavelength measurement, where they say it is this frequency and they've already applied a number. So therefore I can put the color here in this color wheel, knowing that I need at least this many colors, and it's going to say this, this, and this with numbers that are already there. So I have to apply those numbers and make sure that these numbers on the X and Y, because we're going X, Y, Z, so we already have one here, which will be our ultraviolet. Bam! Okay, look at that. Our X and Y. Now we got to find our the Z. Okay, because look, there's a 360 degree whatever. All right, and we're no, at least 6. Okay, so we have this grid of X, Y, Z. All right. So at the very least, I have to go over here into this area and figure out, all right, red, orange, yellow, green, blue, violet, red. So I need here, all right? So if I'm going like this, all right? And we'll call that my Z. All right, I need my X, which is like this, right? It will go like that. That's the ultra. Okay? And then there's supposed to be a number barrier or a number set somewhere in here that would like something like that or like this, depending on how many little things I'm using. Because remember, each one I go out, I'm also going like this. I'm putting in another one behind it, alright? So as I'm saying 3, if I'm going to go 6, I'm going to go like that, alright? So now there's a whole nother one, alright? And then when I go to 12, there'll be another one there. So in the Kenny color spiral, in the X, Y, Z, you know your color's getting pushed out as it's being twisted, spiraled, rotated, alright? Then that is what produces the spiral out. Instead of just rotating a color on its axis. Alright? So if here's this and here's the color, alright? And this is its axis. Each time you go, okay, I know I have to have at the very least 6 for the violet. I have to have another one, okay? But I'm not producing another one here. I'm manifesting it in front of it. I'm actually like basically facilitating this one right here because I'm using this one. I know I'm starting with this, alright? So each time the next one is coming from here because it is actually going out forward, alright? Unless, like, what is that? An electron is supposed to, what's that word when an electron moves? Oh. Quantum leap. That's what an electron does. An electron quantum leaps. It bounces, it teleports into all these little spots that it could randomly be in. And it's like, okay, this is my guideline path. That could be here. Alright? And if you were to look at like that, it would be here, and then it would go up and over, right? So think about that. It's actually traveling a distance, if you want to say that's distance, and then a degree and the angle, right? Because the distance is this long from here. The angle is actually, what would that be? The y, and then the degree would be the x, right? You have your x, y, z, because z is your distance right there, right? So z distance, the angle, which is the same thing right here, is our x, and obviously, yeah. All right, check this out. High as fuck. Z, and there's x, y, and then z. Anyways, you see what I'm saying? Our x, y, z is our distance right there, our angle, and then our degree. You know, because we're hitting it from one point. We have to start a measurement. We have to start a balance. Okay, and so that's when we're saying, okay, if I'm applying some type of degree, I can also apply right there from here, okay? And that's where I'm like, all right, if I have to have 360 degrees of this, that means it has to be 360 degrees out that way. So I gotta have 360 degrees of bam, 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 and it will actually be like the same one going out because it's the starting point that's going like this, that is going like that. So if this is like the balance, the base, your start, and then this is whatever you're applying, your color, like your angle, your degree, your ultraviolet, your infrared.